In this video, we are going to solve work rate problems. Problem 1. Alice can complete a task in 12 days while Betty can finish the same task in 15 days. If they work together, how long will it take them to complete the task? In solving this problem, it is important to identify the rates, which compares two quantities with different units. It is expressed as a ratio or a fraction. For this problem, the quantities that we are comparing are task and day. For Alice, she can finish the whole task in 12 days, so that is one task over 12 days, or it can be written as 1/12 of the task per day. That is how much of the task Alice can complete in one day. How? Let us say this rectangle represents one whole task. Let's divide it into 12 equal parts and distribute it evenly over 12 days. As you can see, Alice completes one of those parts each day, which is equivalent to 1/12 of the task. We use the same idea for Betty. She completes 1/15 of it per day. You can use any of these forms in solving work rate problems. Now that we know how much each person can finish in a single day, we can find their combined rate by adding their rates. One task over 12 days plus one task over 15 days. Isolating the common unit, we get 1/12 plus 1/15 tasks per day. To add fractions with different denominators, we need a common denominator. More specifically, we want the least common denominator or LCD. LCD in simple terms is the smallest number that both denominators 12 and 15 can turn into. We can get this by factoring out our denominators. For 12, that is 2 times 2 times 3, while 15 is 3 times 5. Now, notice something important. Both numbers have a factor of 3. To get the LCD, we only write the common factor once. Why? Because writing it twice would make the number bigger than necessary. However, if you happen to write it again, do not worry because you will still solve it. It's just that it is easier to work with smaller numbers. So, our LCD will be 2 times 2 times 13 times 5, giving us 60. Now it's time to transform the fractions using the new denominator. For 1/12, what number do we multiply 12 by to get 60? We can find that by dividing 60 by 12, giving us 5. To recheck, 12 times 5 is equal to 60. That means we multiply the denominator by 5. And to keep the value of the fraction the same, we must also multiply the numerator by the same number. So 1 times 5 is 5, giving us 5/60. For the second fraction, 1/15, we multiply both the denominator and the numerator by 4. That gives us 4/60. Now, 5/60 plus 4/60 gives us 9/60 tasks per day. But we are asked to find how long it takes them to finish the whole task. In short, how many days? Therefore, what we need is to have a value that is expressed in days per task. We can do this by getting the reciprocal of 9/60 tasks per day. Taking the reciprocal simply means switching the numerator and the denominator. So from 9/60 tasks per day, it will become 60/90 days per task. Simplifying, that's 20/3 or 6.67. That means it takes 6.67 days for Alice and Betty to complete one whole task. Problem 2. Pipe A can fill the tank by itself in 5 hours, while Pipe B can do it in 4 hours. A drain, Pipe C, can empty the tank in 20 hours. If all three pipes are opened simultaneously, how long will it take to fill the tank? Let us first write the rates. Pipe A fills 1 tank per 5 hours, and Pipe B fills 1 tank per 4 hours. Pipe C is a drain, so its rate is negative. It empties 1 tank in 20 hours. Combining them, we have pipe A plus pipe B minus the rate of pipe C. To add these fractions, we use a common denominator of 20 and rewrite each rate accordingly. We have 4 over 20 plus 5 over 20 minus 1 over 20 tank per hour. Since we now have a common denominator, we can only look at the numerator. 4 plus 5 equals 9 minus 1 equals 8. That gives us 8 over 20 tank per hour. 8 and 20 are divisible by 4, hence by simplifying, we get 2 over 5 tank per hour. The question asked for how long it takes to fill one whole tank. In short, how many hours. So, we take the reciprocal. From 2 over 5 tank per hours, we have 5 over 2 hours per tank. Simplifying, we get 2.5 hours per tank. Therefore, when all three pipes are open, the tank will be completely filled in 2.5 hours. In the next problem, Aaron and Brandon together can do a piece of work in 15 days, while Brandon alone can finish it in 20 days. In how many days can Aaron alone finish this work? Let us write the given. We are told that the combined rate of Aaron and Brandon is 1 work per 15 days, while that of Brandon is 1 work per 20 days. Now, we are asked to determine the number of days Aaron can finish the work. That would be 1 work per X days. X represents the number of days Aaron can finish the work. In solving this problem, it is important to note that since the combined rate includes both Aaron's and Brandon's work, we can find Aaron's rate by subtracting Brandon's rate from the combined rate. That is 1 over 15 minus 1 over 20. To subtract these fractions, we use a common denominator of 60. 115 becomes 4 over 60 and 1 over 20 becomes 3 over 60. Subtracting gives us 1 over 60 or 1 work per 60 days. Now, just by looking at the answer, we don't need to take the reciprocal because we can already see that 1 work can be done in 60 days for Aaron. Problem 4. Mike can do a piece of work in 25 days and Carl can finish it in 20 days. They work together for 5 days and then Mike leaves. In how many days will Carl finish the remaining work? Let us write the given. For Mike, his rate is 1 work per 25 days, while that of Carl is 1 work per 20 days. Another given is that Mike and Carl work together for 5 days. To find the number of days that Carl will need to finish the remaining work, we can start by getting the combined rate. That is 1 over 25 plus 1 over 20 work per day. Using the least common denominator of 100, we can rewrite the fractions into 4 over 100 plus 5 over 100. Adding them, we get 9 over 100. This means that together, Mike and Carl can complete 9 over 100 of the work per day. Now, how much of the work is done if they work together for 5 days? Let us multiply their daily rate by 5 days, giving us 45 over 100. By dimensional analysis, we can see that the unit day cancels out, leaving us with the unit work. So, 45 over 100 of the work is completed in 5 days. Therefore, the remaining work must be 55 over 100. Now, Mike leaves and only Carl continues working. To find how long it takes Carl to finish the remaining work, we divide 55 over 100 by Carl's rate. Dividing a fraction means multiplying by its reciprocal, so 55 over 100 times 20 days per work. We can also check this using dimensional analysis. We can see that the unit work will cancel out. By multiplying, we then get 1,100 over 100 days, which simplifies to 11 days. So, Carl will finish the remaining work in 11 days. Let us solve this another problem. A and B can do a piece of work in 18 days. B and C can do it in 24 days, while C and A can finish it in 36 days. If A, B, and C work together, in how many days will they finish the work? In this problem, we are given how long pairs of people can finish the work. A and B can do a piece of work in 18 days, B and C can do it in 24 days, C and A can do it in 36 days. Our goal is to find out how long it will take if all three, A, B, and C, work together. What we can do here is to add these three rates. That's A plus B plus B plus C plus C plus A. Simplifying, we get 2A plus 2B plus 2C. From here, we can observe that each person's work is counted twice. So, the sum of these three rates is actually equal to twice the combined rate of A, B, and C. Hence, after addition, we only need to divide the sum by 2 to get the combined rate of A, B, and C. Let us add the rates. That's 1 over 18 plus 1 over 24 plus 1 over 36 work per day. Using the common denominator of 72 gives us 4 over 72 plus 3 over 72 plus 2 over 72, which equals 9 over 72 or 1 over 8 work per day. Now remember, 1 over 8 represents twice the rate of A, B, and C together. So, we need to divide both sides of the equation by 2 to get their actual combined rate. Dividing both sides by 2, we get A plus B plus C equals 1 over 8 work per day times 1/2. That gives us 1 over 16 work per day. Looking at the answer, we can already see that if A, B, and C work together, they can finish one whole work in 16 days.